Welcome, everyone. Thank you for joining us today. We are the Pittsburgh Jug. I've got Renat here. Renat, do your thing. And then I've got Istvan here, who's our new member of our Pittsburgh Java user group's leadership. We've got Dawn and some other familiar faces, Philip and Aksa. So just want to get started with just like a couple of housekeeping stuff. All our recordings are usually up on our YouTube channel. Please subscribe to it. I think the more recent one went up this morning, right?
Yeah, the
And
one
then
from last month is up as of this morning.
perfect. So, and then we are going to do the same with the one that Dawn's going to cover today. And yeah, do check out the videos. Our official sponsor is BNY. We would like to thank them. And with that, I will hand it off to Dawn. And yeah, I'll keep an eye out, Dawn, as always on the chat and send the questions your way. Okay,
I'll just share my desktop
can see it.
and play. So thank you, Surisha, Renat, and Istvan. Nice to meet you. So today, I'm going to be talking about a book that I recently wrote and some things that you can take away from what I did in the book. So I'm going to share some spoilers about stuff you could learn by reading the book, but I've shared some of these spoilers before in blogs because I think it's actually quite helpful for API developers, which a lot of us exist out there, to learn how to do things like divide and conquer feature-rich APIs, right? So when you're not, necessarily able to follow the single responsibility principle, keep an API minimal. If you've got a large API, what do you do about that? So happy to be here today to talk about this. So a bit about me, so you can get a quick 21-year history here. So I am the author of the book you just saw on the front slide. It's a book called Eclipse Collections Categorically, Level Up Your Programming Game. It just became available on Amazon in paperback form in March, and at the end of April, we now are publishing a hardback version as well. And you can see I have a copy of the hardback here, which is what you saw on the table and the picture on the front slide. So so that came out, just this year, so 2025. I was a contributing author to 97 Things Every Java Programmer Should Know, which came out in 2020. I'm a Java champion. I've been a Java champion since 2018. I am an international conference speaker. I've done keynotes, as well as I usually do 2 to 3 conferences and then Jug meetups like this one every year. So I've been doing that since around 2010. And I am the creator of the Eclipse Collections open source library, which actually I created in 2004. So from 2004 to 2025, that was my journey to, starting building a library and then actually writing a book about it. So quite a long journey. But I'm going to hop right in and describe a little bit about when I started that journey and where that journey led to a problem where I knew I wanted to write a book about Eclipse Collections. After 20 years, it's quite a large library. It's over 1 million lines of code. I think it's about 1.4 million lines of code. Has thousands of types, hundreds of functional interface types. So if you're familiar in Java with types like consumer and predicate and function, these are all functional interface types. Eclipse Collections has hundreds of them. So we've got a combination of primitive ones as well as just more basic ones as well. And then on our parent type is called rich iterable, which most of our types actually extend. There are 134 methods on this type. So the challenge when I was thinking about writing a book was like, okay, I want to write a book about Eclipse Collections, but how do I even approach doing that? First of all, Eclipse Collections as a topic, because it's a data structures and algorithms library, would bore me to tears to write about, and I would never want to read about it. So I was like, problem number one is like, how do I make it fun? But also like, how do I take something this large and complex and actually teach it to anyone? So I kind of set out on this struggle at the beginning of 2024 to figure out like, how do I approach even writing about this? And, through fits and starts, I finally came up with a strategy, which was, and this is, how do you learn a rich API? You group methods into categories. That's all you need to do. Now, the challenge in doing this, so I was able to describe this in a book form. And if you look at the cover of Eclipse Collections Categorically. This is a little game board which shows a path you can take to learning Eclipse Collections. So at the top, you've got an icon that represents counting, and then you've got an icon that represents testing, and then the one that represents finding. And you can see the number of methods from the rich iterable API in each of these categories. And then it goes to filtering, transforming, grouping, aggregating, converting, iterating. And then there's mutating, which is the last one, which looks like the DNA strand. Mutating methods do not exist on the rich iterable API. We still cover them in the book, but they're not on rich iterable itself. So it's not part of the 134. But the nice thing here is, for the cover that we finally come up with, you hear the old saying, you can't judge a book by its cover, or shouldn't. Well, you can actually tell this book by its cover. It's like, this is what you're going to get. It's like, there's no surprises in here. We've taken this rich library, once again, with like 1.4 million lines of code, thousands of classes, hundreds of methods on API, and broken it up into something you can digest. And in the process of doing this, there were some discoveries I made about how other developers can leverage the, Eureka or Epiphany or whatever it was I had, and taking this approach that others could do this as well. And it was borrowing upon, I didn't invent the idea of method categories. Smalltalk has had it for like, I don't know, 40 or 50 years. And that's actually where I first learned about them. But it's interesting because I programmed in Smalltalk in the 1990s, and I had these things. And I learned recently, they didn't call them method categories. They called them message categories. And you can actually read about them in the Smalltalk 80 book, which I have on my bookshelf back here somewhere, written by Adele Goldberg. And they describe message categories. And it was always a feature I had available in the language and IDE. And we would use them, but I didn't really know how to use them well. And it wasn't, once again, until I had this problem, like, how do I take something really large and break it into pieces, right? So there's that. Now I'm going to quickly give a, shameless plug for, what it is you can get out of this book that I've written, right? So first, we've already talked about, you can learn about method categories, and we're going to dive a bit more into this. You can learn, how to organize your own feature-rich APIs. I'm going to show you live how you can do that in your IDE. You can also learn how to reduce the cost to read. So throughout the book, there are over 200, and I think there's over 200 code examples that show different ways of accomplishing things with collections. You'll learn about a practical set of examples of tell, don't ask. So if you've ever heard of tell, don't ask from either Martin Fowler or from the Pragmatic Programmer, this is where instead of asking some type for its data and then doing something with that data, you tell the type to actually do something on your behalf, right? So effectively, like Eclipse Collections has smart collections where like I can tell it to filter, or I can tell it to aggregate, or I can tell it to group, or I can tell it to find something, or does anything satisfy? So all these are methods on the collections themselves. You learn about, and we're going to go into this a little bit in this slide deck, a combination of features that are available. You've got eager, lazy, and fused behaviors. I don't cover fused in this talk, but you'll see them in the book. And we just give a quick example comparing eager and lazy. There are hundreds of Java Lambda examples in the book. So if you're looking for like a book that shows what you can do with Lambdas, this book has a lot of Lambdas, right? Because most of the methods on Eclipse Collections actually take functional interfaces, which allow them to be used with Lambdas. The book is written in such a way, and once again, I told you I didn't want to write a book that would bore me to write and then bore the heck out of me to read. And as part of that, when I did the initial printing of the book, what you'll find is inside of the book, the interior is in full color. I don't know if you can make that out, but basically all the code examples are in full color and syntax highlighted. And we highlight specific sections of code too to say like, okay, here you've got the full context of the code, but I want you to focus on this little bit here, and that's highlighted in yellow. And doing a black and white or a grayscale printing and color printing, it was a no-brainer to me. It's like, even though it adds cost to the the printing of the book, it increases its value because you can open up to any page now and find something that's interesting and inviting, similar to like when you open your IDE. Imagine opening your IDE every day and it was like black and white text. not going to be very inviting, right? So we all, or many of us use syntax highlighting. It's actually helpful, and you actually get a bit of categorization, as it turns out of syntax highlighting. You can tell an interface, let's say, from a concrete class, or a method from an enum, or other combinations of things. So, and then the last thing that's in the book for you is like you can learn the Eclipse Collections featurage API if you want, because we cover everything pretty much in rich iterable, and we do beyond that as well. We cover like some of the set interfaces. You'll see like a lot of the mutating methods for creating collections and whatnot as a side effect of having to deal with collections. So, okay, I'm going to jump quickly to chapter 3 in the book and give you an idea of like what it is you can see. So remember on the slide I showed you, which has the game board of the cover, chapter 3 is really the first chapter where we get into a category of methods, and it's the counting methods. And each category, what we do is we break it down in, to the different things that you may be doing in that category. And in the counting methods chapter, we start off by introducing this bit of text and explanation around this title: eager is easy, lazy is labyrinthine. And this was a section that was inspired by a blog I wrote years ago with exactly the same title. And the reason I like this title is it is so hard for me to say labyrinthine. I have to like I don't know, it's like Susie sells, she sells, but it's like it just doesn't roll off your tongue easily. It's hard to do, and it's even harder to sit down and try and spell, right? It's like, this will spell check you to death in your phone if you try and type it. So, and that kind of actually gets the point across. I'm gonna get to a bit. There's an easier way of saying labyrinthine. I didn't have to be so verbose, but we'll see that in a second. But yeah, eager is easy. That's easy to understand. Lazy is labyrinthine. Okay, that's seems a bit complicated, and that's kind of the point, right? So other parts of the chapter, we show a combination of lazy and eager right away with these two types called interval and interinterval. So these are basically ranges of numbers. Interval is a range of big integer numbers. Int-interval is a range of little int numbers. So it is a primitive list. And Eclipse Collections has a full complement of primitive collections. So we've got primitive lists, sets, stacks, bags, maps, all the combinations, the combinatorial explosion of all the primitive types, all 8 in primitive types times all 8 primitive types. Good fun if you want to code. Thankfully, we have code generation to handle a lot of the code. So it's funny because when I describe Eclipse Collections as being 1.4 million lines of code, we didn't write all that by hand. Code generation does about 800,000 lines of it. So it's about 400,000 that's written by hand. So still a lot of work, but yeah. And hopefully we can all appreciate with LLMs and AI now, like generating lots and lots of code, but we do it as part of our build process, not we don't check it in. So anyways, I digress. So you can learn about counting with a predicate, and I'm actually going to show examples of this. And the reason I'm going to show you examples of this, I want to show you the difference of the cost to read of counting with a predicate eagerly and counting with a predicate lazily. You can count elements by function, you can count occurrences with a bag, and we're going to actually see a comparison of counting with, actually turns out, immutable list and stream, but the API is actually on rich iterable. Okay, so counting with a predicate. And this is actually a snapshot directly from the book. And this is what you could expect to read. This is what the book looks like in print, except for these orange underlines, which I did specifically for you here, so you could see how I calculated the cost. So every example in the book has a cost to read, and you see that right up in the top in terms of a number of books. There's an explanation in the book in chapter 1 where there's a table that explains all the things that go into calculating the cost to read. So it's a formula I came up with, take it or leave it, of how to calculate cost. And in this case, the cost assessed is, I assess what cost of 1 for a lambda. So if you see on line 6, you've got a predicate. That's actually a lambda we're creating. Now it's actually a lambda, but it's also calling 2 methods. So every method call gets assessed a cost of 1 as well. So what happens here is I'm giving you a free method call, but I'll count it. So counting years in size as part of a lambda. So you get the lambda for free here because I'm counting years here. But basically, so you get a cost of 2 from that, and then you've got the cost of the the call to count, which is then passed in the lambda. So a cost of 3. What you see here is, so we have some type called generation. We're actually going to see the generation code a little later, at least some of it. So generation is a type that's used throughout the chapters, and generation is what you would kind of expect. These are like generations like Generation X or Boomers or Millennials or Gen Z or the Greatest Generation or the Silent Generation. We go all the way back to the Progressive Generation in the 1800s, right? So you can actually, in the book, not just, and I didn't list this in one of the benefits, but you can learn about generations. And as it turns out, you can learn about US presidents as well. Now, I'm not going to be covering US presidents in this slide deck, but if you want to learn about all the presidents since the 1900s, they are in the book. You can get a bit of history. In fact, it's an interesting intersection of generation and president. Both from a birth perspective as well as years served in office. So some very interesting things. Actually, I got to discover, which I didn't know as I was writing the book. So it's kind of fun what you get to look at and how you then actually can use a query. So here, or use things to query. What's interesting here is I'm counting, I'm saying like, hey, for a generation, give me basically all the generations, count them up, where the number of years in that generation. So the years basically is going to either be an interval or int interval. And if the size of that range is greater than 15, I want to see how many generations have more than 15 years, right? So that's why I call it more than. It's checking to see years size greater than 15. And if I count that, you'll see in the generations that I have in the book, there are 11 generations that have more than 15 years. There are 0 that have less than 15, 0 equal to 15. There are 3 that are equal to 16 years, and there are 2 that are equal to 17 years. So if you're curious, in the book, you can find out which generations have 2 years and which ones have 3, right? So, and actually, you might be able to piece it together when you get to the generation page, because you'll be able to see the number of years and you can start to do the mental calculations if you want. At every code example in the book, you'll see these little annotations over to the right in circles, right? So they have a number associated with them. And instead of having comments in the code, I wanted the code to be as readable as possible. And then there are comments at the bottom. So for each annotation explaining what that code does, right? The intent being that like, if you can't read it, this will help you at least understand what's in there. So I do that for every single code example in the book. It's hopefully adds some value as you're reading it. So, okay, so that was counting with a predicate. And count is a method on the immutable list type, if that wasn't clear. Count winds up being an eager method, it returns an int, right? And if we switch now to counting with a predicate and stream, and actually I took this instead of from the book, I took this actually from the code base I use for all the examples in the book. So I wrote this now with stream. Now, immutable list has the ability to actually give you a stream, right? So you can see like we have all the generations. So this is all the instances of the generation type, which we're going to see in a bit. And we use the same predicate, so gen years size greater than 15. We, from the immutable list, call dot stream. So that's one cost we assess, right? Then we have to dot filter. We still have the cost of 2 for the combination of lambda and the extra call to size. So that's 2 more in the cost. And then we have to, in order to calculate count, we have to call this final count method. So we had to do stream filter, pass in a lambda, and then call count. So that's how we do counting with stream with a predicate. So you can see this actually then adds up to a cost of 5, right? And if we zoom in and compare these two things directly, where we've actually inlined the lambda, right? So we're not extracting the lambda in a separate type called predicate, generation. We're actually inline it in both cases. In the top case, you can see the call to count with the lambda inlined and being assessed a cost of 3. And you can see this is an eager method. Count is eager. It's not lazy. In fact, it's not lazy on stream. Stream, when you use count, though, you're forced to, if you actually want to count with a predicate, you have to do a filter first. Filter's lazy. And what you'll see is like the shorter word, remember I described before, labyrinthine is hard to say, hard to spell. The shorter word for labyrinthine is called mazy, which is nice because it rhymes with lazy. And you can look it up in the dictionary if you want. You'll see the synonym for mazy is labyrinthine, right? It's like, why couldn't Don just say mazy? It rhymes and it sounds cool. it wouldn't get across the point. Labyrinthine, it's harder. But you can now, once again, quickly see this comparison, the cost of 3 versus the cost of 5 and looking at them directly. So you can see you just have less methods being called, right? You've got 5 methods being called versus 3, right? Easy enough to do. It's not rocket science here. There's more for you to have to understand and reason about doing. One thing you do get with Stream is you get the ability, because Stream can be larger than a collection which has a int size, you can have a much larger count. So if you're streaming across a file or something else which is bigger than a 32-bit size, you can actually have a larger count. So that's a functional then requirement. Like if you've got more than 2+ billion things, using a stream counting is going to be nice because you're not going to be limited by the 32-bit int. So okay, so I told you how I would give you something to walk away with in terms of developing your own APIs and how you can actually introduce method categories in your code. So one of the things I did as I was writing the book, I went back to the Eclipse Collections code base and I categorized all the methods in rich iterable, because I learned via the internet after some conversations on various social media platforms with 2 developers that IntelliJ has this neat feature called custom code folding regions. And what you see, this is actually a picture of the rich iterable type in my IDE. And on the left, I've got the structure view, which normally in the structure view, it'll typically show you the variables in your class and the methods for your class or type. And what I've actually done is I've created my own groupings, right? So I've created my own custom code folding regions, and I've categorized methods. So you can see the categories which match the categories on the cover of the book. It's like aggregating, converting, counting, filtering, finding. And I've assigned, lo and behold, I discovered this along the way. You can actually use emojis in the text, and you can actually see the emojis over on the right. So if you look on the text on the right, that's the actual source code. And if you see there are comments, you see / region, category iterating, and then a emoji next to it, that's actually what's showing up on the left in the iterating category. And you see the same thing for like category counting with the 1, 2, 3, 4 icon. That's where it's picking up. So the text on the right and the comments actually being picked up by IntelliJ in the structure view on the left. And later we'll actually jump into IntelliJ and do this ourselves, because I learned a bunch of different things along the way as well. I don't use nesting, but you can actually nest code regions. So you can actually do multiple levels. So if you, for instance, like split something into a category and it's got 100 methods in the category, you may want to break that category up. And actually, if you look at the categories in Eclipse Collections, the one category that's quite large, and I would probably break it in half, would be converting. And the reason converting is large because we have converters to both mutable and immutable collections. So imagine you broke it in half, and that's effectively you'd have convert immutable, convert mutable, and it would probably split near the middle, right? So you'd wind up with 15 apiece as opposed to 29. Okay. So yeah, so this is what it looks like. And you can see the benefit is like now I can, instead of looking at 134 things, instead of scrolling through the file, which maybe has like 3,500 lines mixed with JavaDoc and who knows what else, trying to like parse it with my eyes, and I'm going blind and not great. Over on the left, I can see like this nice tree view, which I can just expand the things I'm looking for. And the methods are actually sorted. They can be sorted in counter order from the file, but you can sort them alphabetically as well. And this is both the category names as well as the methods within them as well. So you can see these are actually sorted alphabetically. So over on the right, if you look at iterating, you can see for each actually shows up first, but on the left, as lazy shows up first, right? So it's actually sorted alphabetically. So that's that. Now, I told you before that we would eventually see the generation code. So this is actually what generation looks like in the book. So when you see, and you can see the code listing at the back of the book, I actually show it as it gets introduced in chapter 3 as we start to learn counting. And you can see like generation is an enum. There's a set of generations in here. I go all the way back to 1776. a famous year, but I call that unclassified. It turns out there are generations for that time period. I just didn't feel like breaking them up because I only went back to presidents until as far back as 1900. There was a specific reason for that. At the time I was writing the book, which was 2024, I didn't want to add, there was a president in the 1800s that had 2 non-consecutive presidencies. It was Grover Cleveland, I believe. So if I had non-consecutive presidencies, it would have complicated my model a bit because I'd have to model a term. And I just wanted to have a start and end date. So it was simpler to just, for the historical presidents I looked at from 1900 to 2024, you know, presidents only had a start date and end date, even if it was multiple terms in there. So that said, generations go this far back. You can see all the way back to progressive. Now you can start to, if you wanted to mentally calculate which of these generations had 17 years versus 15 years, so on and so forth, or greater than 15 years. You can see which ones are which, sorry. Now what I did is I actually went through just yesterday and I said, okay, let me categorize the methods in generation. I didn't do this in the book. So I've done that just for this talk. And you can see what I did. And it's a little bit larger text now. You can see I've added custom code folding regions for the data. So in the data, I'm including the instances of the enum, so everything from unclassified to alpha, but I'm also including these one public static value called all, which is what you saw in the code before when I was saying generation.all. This is where it's coming from. And all it's doing is taking the array of generation values and wrapping it in an immutable list and storing that. And that's so I can use that immutable list anywhere in the code in the book. So that's where that's coming from. The by year actually does a grouping, which you can actually see part of the code that does the group by year. It's somewhat complicated. I explain it in the book. It's using a special method called actually nested inject into. The reason I'm doing that is because I wanted an immutable int object map. We do not have grouping in Eclipse Collections that deals with primitive maps or primitive multi-maps. We don't have primitive multi-maps. It's one of those things that like, hey, it would be neat to have primitive multi-maps, except that that's probably another 500,000 lines of code you'd add to the library. I'm sure everybody would be happy with that, both the people who have to write it and the people then have to consume it. So we haven't added that yet. We haven't had the need, but you can actually simulate the multi-map using a primitive map. So, and that's why I'm using inject into. If we had group by that did primitives, we'd have like group by int, group by long, group by double. We'd have to support all 8 primitives and then, you know, all the multi-map types. So we don't have that. But anyways, over on the left, you can see I've created 4 method categories. So I've got one for accessors, which are effectively getters. I could have called them getters, I guess, but it could be accessors could actually be both getters and setters, right? If you had them. I have a category for filtering, category for finding, and I've used the same emojis that I used for Eclipse Collections. Turns out these categories are actually somewhat reusable, as you can see, right? So finding category has a method called find. The testing category, now you can learn a little bit about what testing means. In Eclipse Collections, testing is like any satisfy, all satisfy, none satisfy, but it's also equals, it's contains. It's basically any method that returns a Boolean is a testing method. It's like, because you're testing a condition. The condition may be specific. You either use passive predicate that tests a condition meeting either any, all, or none, or it's more specific like containment or equality. But you can see the data grouped on the left. And now you can see the nesting. So if you look under instance on the left, you can see, and you don't see it on the screen, we'll jump into my IDE in a second. So I broke instance up into constructor and then variables, right? So generation has 2 variables. It's got the name and then the interval for the years. And with that, I think I will switch to my IDE so we can actually go see it. Okay, here it is. And what you'll see is like, if I start typing in here, blah, blah, you see it's automatically changing the code on the left or the view. So that's how it only uses the text from the region tag. The end region's not important, but I like to have it match. But yeah, so we can just introduce a region. So for instance, we could add a nesting region nested region and call it, let's say, unimportant. Someone might have said, hey, you're missing something. And I said, yeah, you're right. Okay, so we just have to add region and then end region. And now when we look at data, we'll see unimportant is here as well, which has unclassified, right? Now there are two ways. So there's region end region is one approach to use with custom code folding regions. Another one is if you right click on two things. I think we can, didn't try this before. Let's see. No. I forgot how to do it now. There's a, let's see, it's under edit. Oh well. I should have thought about this before I did the demo, but there's a way, there's another tagging thing, and I forget what the name is. I could probably like search through help, but I won't go do it. But basically you can either use region end region. There's another tag that you can use, which is, I believe, IntelliJ specific. And that's one of the frustrating things about using custom code folding regions is like, I believe region and end region, I went with it because it is supposed to be supported in both IntelliJ and VS Code. So this should work in VS Code as well. I have not tested that. So if anybody is curious, you can always check out the Eclipse Collections code, which if we look at Eclipse Collections, I've got it here. You can see these are the categories for rich iterable, and you can see then the larger number of methods. And this allows you to then just easily navigate around to stuff. This is available when we release Eclipse Collections 12.0. When you take the jars, this view will still be persistent. It's not just in the source. It'll be consumable in the library as well. So the structure that you apply here via the categorization will still apply. So let's see. Yeah, so I think, you can see the nesting here. I had a region for instance and then region for variables, and you can see the variables are name and interval, int interval. And then I have the region for constructor. I used a little construction icon, thought that was cute. And I guess if you had multiple constructors, then you could have them grouped together. But pretty much like this is how you can simulate method categories in Java today. One of the things that I've been doing quite assertively is talking to the core teams at Oracle and any Java champions I can converse with to say, we need method categories in Java like 30 years ago. So let's get them in there, because the place, and I'll show you this in a second in the presentation. So the place where you would also benefit from JavaDoc besides the source, I'm sorry, by method categories would be JavaDoc, sorry. Stumbled on my words there. So if we had categories in JavaDoc, this is how I'd want to actually see JavaDoc at the top. Right now, if you go into JavaDoc for a class, what you see is like this long list of methods, right? And it will be voluminous based on the amount of text for each method in the JavaDoc. Now, I think there's a left pane now in the latest version of the JavaDoc tool, which you can zoom into individual methods in that, but you're still scrolling through all the methods, which if you got 134 methods, that's a lot. So the nice thing, if you could actually have JavaDoc generate a summary organized by a tag you could apply to each method where it's a method category, you could generate something like this. Now, I did this by hand. So if you go into Eclipse Collections and look at the JavaDoc for rich iterable, you'll see at the top, let me just move this out of the way. Okay. You'll see all this stuff that I typed by hand, which would be painful to have to do, right? So this winds up being, when I hit, if I go to the type rich iterable and I want to look at the JavaDoc for this, I can just do Control Q. And there it is. So this is the JavaDoc for the type. And what you see is, because I've included all these methods organized by category in here, I can click on any one of these and it's going to take me to the JavaDoc for that. So I get all of the JavaDoc nicely organized by category for something that's quite large, but it fits on the screen. it's impossible to fit all these methods on a screen. It just won't, right? You'd have to have like a really, really tiny font. 134 is just way too big. Or is it actually, it's not, easily compressed, but on my big screen here, 27-inch monitor, it, with the right number of pixels, it's actually displayable and navigable, right? So I can like quickly navigate through that. If I'm navigating in the code, it's kind of interesting. All of these become actual links as well. I can actually jump right to the method in the type. So, and you have the ability in IntelliJ to either look at this view or the rich text view. So if you click this button, you'll see it switches to the readable view. Which, I can see now, hey, the category's over here, the category's over here, everything nicely organized. So that's that. And let me not do that. We'll change Eclipse Collections in this doc. So let's see. So yeah, my hope is that eventually we will get categories. Instead of having to use custom code folding regions, we can just assign and tag categories in Javadoc. And then the Javadoc itself will be generated, as well as that nice view in IntelliJ or any other IDE can be picked up based on the metadata for our methods, right? So that's ultimately what I want. I want to have, once again, the same experience I had 30 years ago when I was programming in Smalltalk. I think, once again, in my view, it's time to have it. It shouldn't be hard to add. I think it adds value. It actually will allow us to focus more on our documentation and how we actually then organize things for developers to be able to learn. And that gets back to like what the whole purpose of me writing this book was. Like I wanted to have something that is able to describe this million plus lines of code, thousands of classes in a way that's enjoyable, but I can, build upon the learning, and I can then, have something that's more fun to read, and has a more fun book cover and all the stuff. So, and that's that for what I had in the slide deck, and I can do like Q&A, but if you want any contact information, so I blog on Medium. I'm on Blue Sky. Um, I'd like to tell you get a 404 if you look me up on X, but no, I'm still out there. I don't follow anybody, so I'm not reading content there. Occasionally I'll post something out there just because I know there are still people that follow me there and haven't moved to any other platforms. But my preferred platforms are Blue Sky or Mastodon. And then you can find me on GitHub as well if you want. So with that, I will stop sharing. I don't know if we can do Q&A. Folks want?
Yeah, we can totally do that. And Philip, you're like literally the only person here, so you can come off mute maybe. So
Wow,
yeah, we can like stop the recording here, maybe Renat, when I don't know if you want to do that, or we can just continue to do this session
Yeah, I mean, I can figure it
later.
out later.
Okay, okay. But yeah, I feel like I don't know what's happened with our meetup registration, and Renat was just finding some things on our meetup attendance page, and I think we probably need to look into some of our membership and things like that. I think we were supposed to approve certain things. I'm not sure if that went into this. But firstly, thanks a lot, Don, for spending the time with us. And obviously, this recording will be up on YouTube. Philip, do you have any questions for Don?
No, I don't have any questions. I just, I'm really impressed with the attention to detail with this. It's pretty cool. But like, like literally everything that you say starts a new process in my mind about, geez, code annotation and the other facilities that other languages have, and it's not new. It's like
yeah,
30 and 50 years this stuff has existed, and it's just like people don't know about it, and I think, it makes me feel like really old to have this feeling where like like n nothing that I think is cool is new. And it's just like every time I see things like this, it's just another reminder of like how there's so much stuff that exists, and people don't know about it. And I start to think like, geez, how could we improve on this? How could we fix this? Is it even a problem? But it's like, you know, at this point, I just think it's art. It's just like, you know, it's obscure knowledge. It's just cool to know. It's really useful, but you know, if there aren't billionaires making money off of it, I don't think that it's like cool enough for everybody. So that's just my thoughts. You know, I could ask questions for hours, but I don't have anything specific.
Well, you can if you want. I will answer them for as long as I'm conscious. Oh, actually, I just want to say, Philip, thank you for that comment, because it's nice to hear that, because yeah, I have spent a tremendous amount of attention to detail in the writing of this book. And once again, and I did this early when I discovered that I could actually use custom code folding regions. I blogged about it almost immediately, right? So I tried to share that right away. It's like, okay, I've got this eureka of like, hey, method categories. Now I didn't, like I said, I didn't invent it. You know, I had it in Smalltalk. It's just I never recognized it was missing in Java.
Hmm.
And it wasn't until I had to teach in a book form 134 things. I was like, how do I group this, right? Because I was like,
Yeah.
the initial inclination when you're teaching data structures and algorithms is either to start with data structures or start with algorithms. And I went somewhere in between, which was like, it's categories of algorithms, right?
Yeah.
Where I don't know that I've never seen a book that does that before. So if anything that's unique, it's that, right, that I've done. In the process, I got to learn some things about Smalltalk I didn't know. They didn't know it either, which was like, while I learned about categorization of methods from Smalltalk, um, they hadn't looked at, I think, how their categories were distributed. Because remember, I described like right now I've got the converting category has 29 things in it. I'd probably split that in half. Because I tend to follow the, you know, old adage of 7 plus or minus 2 things that you should have, you know, to help, you know, short-term memory, right? So, and this is a basic information chunk and concept. So again, I don't invent these things. They've been around for, that's probably been around for hundreds of years, right? We've known it. That's why like phone numbers are the way they are, and you know, other numbers, social security or otherwise, are the length they are, so people can actually have a chance of remembering them. But yeah, it's interesting. So Smalltalk, as it turns out, for their collection API, and I just think I think it's because nobody ever looked. If you look at the distribution of methods, they've got some categories with one method in it. It shouldn't be a category, right? Category one doesn't sound right. And then they've got one category that has 43 methods in it. So it's like they have these bar charts with like very small things and like this huge thing, right? It's like, did you look at that? So it's funny, as it turns out, their category that has 43 things in it's called enumerating. And guess what? That actually winds up being the category I broke up in the book into 9 categories, because it's like counting and aggregating and grouping.
Right.
These are all things that they just lumped into enumerating, right? But it's like you have to take a different view. It's like, which is I think the view I was taking, which is like, how do I get people to want to learn this stuff and sit down and
Yeah.
want to actually read through this? And it's like, I don't want to read through 134 things, at least in one sitting, right? It's like, and I don't want to go alphabetically. I'm going to get lost. Like, give me something that I can sit down, maybe I read a few pages, and every time I open the book, I'm not lost as to where I was, like,
Mm.
you know, graduating, or I can use it as a reference and go back and forth. It's like, I'm looking for something that does X, and it feels like a transformation. So let me look in the transforming
Yeah.
chapter.
Yeah. I think definitely it has like that API driven um book reading or book whatever style. Like, you know, it's not on data structures or on algorithms specifically, but it's more like if you wanted to do something, you know where to go look for it. So it's definitely API driven in that sense.
Yeah, and I do. It's funny because I know, like Surisha, you've seen the book, and chapter 2 gives you an overview of the whole library, which
Yeah.
really takes the more type-driven view of like, okay, we've got this parent type and the subtypes, and you learn about symmetry that exists in the library because we have support for readable types, immutable types, mutable types. These are the collection types we support. These are the combinations of bags and multi-maps, and we support primitive and, you know, object types. So you start to see the patterns, but it's without like just blinding you with like the details of the million lines of code. It's like giving you enough information to know that, okay, when I'm looking for stuff, I know how to navigate, because guess what? The packages in the library are organized in such a way. And actually, let me show you that. I'm not going to show you the book. I'm going to show you the library itself. And we did this a long time ago for specifically this reason. So you see how we're looking at reach iterable and we can navigate, right? and drill into things as we want to. Am I sharing okay?
Yep.
Okay, so if you look at am I in Eclipse Collections? Yeah, so in Eclipse Collections itself, you've got two jars. You've got the API jar, and we broke API and implementation into separate jars. And I described this in the book via two mind maps, and they are the most beautiful things you've seen in color. I loved looking at these things, and they're side by side in the book. It's actually my wife's favorite pages in the book as well. Like, oh, it's so pretty. She loves it. I was like, okay, that's nice. So it's interesting though, like if I look at the API jar and I explode it, you can see like source main Java, and you see there's the root package, right? And this is unlike what you'll see in most collection frameworks. The collection frameworks you'll see that are like this, or I think Apache Commons does this, is the one. I think maybe Vauver does. But basically, beyond this, like the types are actually organized by, so these are actually all interfaces. So you'll see like we have bag, and then we have primitive, which we won't see in the source here because I actually, you know, let me look in the, I'm going to look in this project, which actually takes Eclipse Collections as a dependency. So you can see this not just in the source for Eclipse Collections, but in the library itself. So if I look at the API jar, which I was just looking at, you'll see the same structure, so the packages, right? And if I look at bag, and now if I look at primitive, you'll see like they're all the primitive bag types. And the reason they don't show up in the source view is because they're generated, right? These are all generated out of templates. And that's actually a good example of that. You can't find this in the source, but they exist generated in the resulting jar, right? So there's all the actual source that gets generated. And it's compile time generation. But you can see like I've got bag, bimap. So all of these things, okay, you guys will get an extra treat. I will show you in the EPUB, which this will eventually be. So I'm working on the Kindle version of the book. And if we look at the package hierarchy, it's in chapter 2. Oh, there's one of them. So this is the API jar exploded out into the directories, right? So these are all the directories in the API jar. And what you can see is like, the nice thing with a mind map is that it can easily fit, you know, literally twice as many things as well as the detail, because it's not just vertical, right? I'm not just exploding them all vertically. I've got two sides to explode in. So both for the implementation jar and for, so that's the impl jar. So if I look at the implementation jar, so that's this one right here, you'll see these are all the packages. So you can see once again this type. So I see bag again. Now these are the actual implementations of bag. So there's abstract bag, there's mutable bags, there's immutable bags, right? And all the actual classes that are written. Then the primitive versions as well, which is voluminous, right? Now, the nice thing is this view, this is literally all of the packages that exist in Eclipse Collections, the impl jar, down to the leaf. I don't show the classes. These are all just packages. But the nice thing is like in two very summary views, this is the entire package hierarchy of Eclipse Collections. So again, representing 1.4 million lines of code, thousands of classes. We tried to present the library, and this is what I'm getting back to. We wanted to make it so that if you were in your IDE, you could actually find stuff by just navigating through the tree view. And it's because they're actually grouped together. So you see a categorization built here, right? Here we're categorizing by type, or grouping by type. It's a better way to say it. So I group by like map and then sorted map within it, right? So, and you start to understand that, and you'll see the similarities between the Eclipse Collections implementation. So like I can look at list and you'll expect to see, oh, well, list, yeah, I want to see immutable sides of the list, but oh, there's this other thing called fixed. What's that all about? And this is actually, these were some of the first types ever created in Eclipse Collections. You can hear about this story or read about it in the book where it came from. These were like the first types I ever created. Some funny named types. But anyways, so yeah, so once again, it's like I've been for years working on this library, trying to focus on the attention of like how can we make this something that people could actually navigate and understand? Because like it was large, it kept getting larger, and how do you break that down? And we had to solve these kinds of problems over the years. Like we went from something that was small, and we went from like utility only to, let's say, mutable types, and then we added immutable, and like now we had to sort out like, well, how do we deal with mutable and immutable and readable, and how to structure that? And we had the benefit of, when we introduced these things, reorganizing. We had 3 times we could reorganize all the packages. When it was an internal framework at Goldman Sachs, it was all in packages called com.gs.caramel. And when we open sourced it as GS Collections, it became com.gs.collections. And then when it became Eclipse Collections, it became org.eclipse collections. So we had 3 times where we could refactor the packages, because people are going to go through the pain anyways. It didn't matter the package hierarchy, but we wanted something at the end. We can't do it again unless I forked the library again, then who would ever use it, right? I wouldn't. But we've had the ability to actually organize things so they could be, hopefully consumable. And it's funny, part of being consumable, I would say, is like, if you can actually explain it, it's probably consumable. If you can't explain it, it's not. And that was kind of a goal for me, is like, I wanted to be able to explain things. And it's funny because that view I just showed you with the mind maps, when I started out writing the book, I was taking snapshots of pictures of the tree view from IntelliJ to show the package hierarchy. And guess what? It didn't fit on the screen. And actually, I got feedback from one of my reviewers saying, like, I don't know what you're trying to show me, because all I could show was like a portion of it. It's like, I don't really get what am I supposed to figure out from this? And I'm like, well, you're right. I'm going to either show you the whole thing or not show it at all, right? So, and the mind map approach actually helped me to find a way to actually show it all.
I actually have a little bit of feedback. Like, I really appreciate understandability. Like anytime anybody says that word, I'm like, yeah, understandability. We want to understand things. Not all of us, but the people that want to know what we're talking about, we want to understand things. But as you were going through your demo, when you first put it on the screen, I saw you had the generation there, and you had previously been mentioning code generation, and I thought you were actually going to you actually had a demo ready to go of how the code generation was, and then you started talking about the loss generation, and I was just like not understanding
too many generations.
it was just a language thing. But, it wasn't clear to me, just with my own intuition of where we were going with this demo.
Yeah, I'm sorry. I hadn't even thought about the mixing of generation in that context. I hadn't planned about talking about code generation. That was just more of a, throw it out there. So apologies for any confusion I may have caused in my, random word salad.
No, but at least like next time when you do this, maybe you can separate the two, or maybe build the context around the data points, maybe, or something around. Yeah.
Well, it's interesting because eventually what I want to do is I'm going to turn this whole book into a code kata, so that you can take it. So you will be able to see generation out on the web eventually as well. So all the code examples, you'll be able to write them yourselves, following along in the book if you want, or just solving them yourself, right? You'll have all the test cases written. So
yeah, got it. Thanks a lot, Don, and thanks, Philip, for all the questions. Thank you, Renat and Istvan as well, and we will keep in touch.
Yeah, and we'll put this recording up in a week or two, or maybe faster. Who knows?
Yeah.
Now, it's funny. I don't know if you can tell, the sunset's coming through my window here.
I can see that. I can see that. It's the same with me as well.
It's like I'm like a different shade, the color shade. So, but okay, awesome. Well, thank you for inviting me.
Thank you, Don. Yeah.
Thank you so much.
Thank you so much.
Awesome.
Thanks,
Have a good
everybody.
evening, everyone.
Yeah.
Thank you.
Bye-bye.
Bye.